This is our interim presentation for the analysis and redesign of a trolley cart, presented by the members of Team 2. Our product is a general-purpose trolley-style cart. It's made to transport items of various sizes and weights. Its features include 2 trays, ergonomic steering grips, fixed wheels, as well as collapsible tubes for ease of storage. Our anticipated production volume is 201,000 units per year. Here's a simple exploded view of our assembly with all parts excluding fasteners. Our customer base consists of 2 customers. Our primary customer will be the office or corporate setting, machine shop workers, and food industry workers. So these industries all have something in common. They have large workspaces that require transporting of items from one side to another on a daily basis, whether that's office supplies, food supplies, or tools. Catering a product to these industries, which are globally present, would both be helpful to them as well as yield a successful product. Our secondary customer base will be the film production, industry, and media companies. The trolley cart lends itself to customization, which allows for addition of attachments that can be very industry specific. So with this in mind, film and media industries can utilize these types of carts for transporting expensive equipment, such as computers, cameras, boom mics, and things of that nature, as well as actually using the cart to film.
We completed a fast diagram to illustrate the functional analysis of our product. All functions are in the form of functives or verb plus noun. Some important functions include to enable translation, to allow portability, to distribute weight, and to maintain structure. Next, we drew fishbone assembly diagrams to illustrate 2 feasible assembly sequences of our trolley. The first assembly sequence is quite realistic. Our trolley is constructed from bottom to top, which allows for the sub-assembly to be tested as our product is assembled to ensure wheels roll properly and ensure the collapsibility of our mechanism. The second assembly is also quite realistic. In this assembly, the trolley is constructed from top to bottom, which enables the support tubes to be attached more easily to the bottom shelf. On this table, we compare sequence 1 to sequence 2. Sequence 1 received a better score for ease of transferring and handling, since the secondary assembly makes it challenging for handling because it's difficult to align the support tubes into the mounting mechanism. For the second criterion, ease of locating parts is the same for both sequences since the same size and shape of components are used during each assembly. For the third criterion, the ease of fastening is better for sequence 1 since it's difficult to attach the mountings and bushings when the assembly is large in sequence 2. In sequence 1, the most difficult fastening is done early on. For criterion 4, sequence 1's bottom to top assembly enables the sub-assemblies to be tested as the trolley is constructed, like ensuring the wheels roll properly and that the mechanism collapses. For the fifth criterion, ease of assembling in parallel is better for sequence 1 since the modular assembly is done early on, like attaching the wheels and brackets on the bottom shelf. As you can see, sequence 1 overall received a better score than sequence 2, making it a better choice of assembly. Next, we made a component mapping matrix. The functions shown on the top of this table are directly from our fast diagram.
The quantity, material, manufacturing and assembly process, material processing and assembly costs, tooling cost per part, and the total unit cost. Some of the key things to point out are the high prices of some of the purchase components, such as the first one, which are the 4 wheels at the bottom of our cart. Searching for alternative parts should be considered to lower the cost, but doing so without sacrificing the performance of the cart. Another thing to point out are the components with many machine features that have high processing costs, such as the flat bracket. These parts should be reevaluated using DfM to drive those processing costs down. Next, we have the 4-quad chart where we have the part name, whether that part has low or high functional importance, and whether it has low or high manufacturing costs. If it has low functional importance and high or low manufacturing costs, consider eliminating the part, such as the upper angle bracket. If it has high functional importance but low manufacturing costs, keep it as is. such as the grip. If it has high functional importance but high manufacturing costs, redesign through DfMA, such as the top and bottom shelves. It is also important to note that the current design has many fasteners that could also be eliminated through DfMA.
For product family design, we will look at two variants of a similar product, one of which is more suited for commercial use and the other for more professional use. When looking at the product family design, we have to first consider the shared interests and the differences between consumer groups. For example, all consumer groups want to enable motion, distribute weight, and maintain structure while maintaining cargo. However, there are considerable differences in the translation, the portability, and the mounting between the groups. As a result, we have to consider the platforms and the modules so as to create the family design. For example, the bottom shelf and the support tubes are platforms because they exhibit a great amount of cost within the bill of materials, meaning they are essential to the core product that is the trolley. Whereas the modules are more modular pieces, which inherently cost less, such as the wheel assembly, the lower mount, and the handle. For the wheel assembly, when looking at variant 1, there is an increased portability through the sliding of the slider, as well as increased strength through the use of stronger materials. Whereas variant 2 is more suited for commercial use through the use of bearings that allow for greater control. When looking at the bottom tube support, variant 1 allows for the pivoting of the tubes, which enhances the portability of the product, whereas variant 2 allows for greater strength through the rigidity. When comparing the interfaces of these two, it becomes very clear that they share a lot of commonalities. They both go through the same holes and are located in the same general areas of the bench. When looking at the handle, there is a higher amount of linear translation that comes through the use of the grips, whereas the bar facilitates greater motion through higher torque applied on the sides. When creating an assembly sequence, we have to keep